All right, so when I gave you guys the practice test, the answer key specifically, you never have to do the practice test. It's just another study piece for you, right? But dear God, don't do this. Practice test answer key, right? Don't do this. Yeah. That's what I would do. Yeah. I mean, because if you agree with something that's already done, you're going to build false confidence in your ability, right? You guys understand what I'm saying? So if you don't do the practice test, don't even look at that. Don't look at that. There's no point to looking at that, right? It's easy to agree with something that's already done. So the right kind of way to do that is do the practice test like it's a real test. Check it against the answer key. Anything you had trouble with, you go back to that section and focus on it. That's how you study and get ready for the test. See what skills you need to work on and then work on those skills. Cool. I like it. So when we're kind of transitioning now into review. So the way that review works is it kind of depends on you. We could talk about any damn thing from chapter 1 up to chapter 8, because that sounds horrendous, but that's basically everything from there could be on this test. Obviously, the big thing to focus on would be factoring, right? That's huge. The more you can factor, the easier chapter 7 is, for example, right? So what can we talk about today? We can talk about specific things on the practice test, specific homework problems. We can talk about general ideas of things. Why does this work? We can talk about quiz corrections. The quiz you just got back today, you can work on that. You can ask questions. It's wide open, though. And it does sort of depend on what you want to talk about. Now, if you don't want to talk about anything, that's got me worried a little bit, but, that's a choice. That is one of the options. Whatever you want to.
Can we go with D on the test? I know it's kind of subject, but...
On the quiz?
Yeah. No, the test, the practice test?
Well, 1B? Or 1B?
1B.
Okay. So, obviously in 1B on the practice test, what's the very last thing you're going to do?
Before part 4, Or you divide the
Yeah, the division is the very last thing. You got to do all the top, get a number, all the bottom, get a number, and the very last thing you're going to do is that division, right?
Yeah, anymore.
Yeah. Let me see if I have one without my writing all over it. I have a bad feeling I don't, but that's all right. You can have this one. You like this one even better because it's got all the work for that on it. All right. Anybody need an answer key while I'm thinking about it? Practice test answer key. Everybody has one? Okay. Oh shit. So I just gave away my last copy. Did I answer that last question all the way? You good?
Yeah.
You sure? Not really. No. Because all I did was say what you do last.
Yeah,
So like, what do you do in the middle?
I did it's 27 plus 2 divided by 9 plus 1, which would be 10. But I just don't see how on the answer key you get 6 there.
Oh, good. Thank you. That won't help me now. Oh, no, the answer key. It was the original problems. I don't have anymore. So you're okay with that first step I have on the answer key, right?
Yes, I just don't understand how you got 6 as the numerator at the very...
Alright. So on that 1B, is everybody cool with how I got to here? I'm skipping a few steps there, but I'm like the only one allowed to do that. Nah. So on the top, just look at the top. These are two separate problems.
You guys divided the 27
Yeah,
by 9, right?
division comes next on the top.
Okay.
So again, it's because of this big-ass bar being last, our brain says, oh, division is always last. But that would be an entirely different problem. If I put parentheses in here and here, that is a completely different problem. What comes last up top is the addition. PEMDAS, is after do, right? So the next thing is divide. So there's your 2 plus 3 plus 1 here. Cool. I like it. Yes.
Can I ask for a different problem?
No, that's the only problem I'm going to talk about.
Number 3.
Oh, I guess. All right, so number 3 gave you this. All right. If I ever say, find the equation of the line that does stuff. What's that? Oh. What 2 things do I need for the equation of a line? Good. I need the slope and a point. We are synced. Testing. It doesn't matter what I say after this. I can say that go through these 2 points, and then you use y2 minus y1, blah, blah, to get the slope, and then I give you 2 points, you just pick a point. You guys kind of with me? No? Yes? Yeah, we don't want each other. I don't. You got a big group of people that is like, I don't want to give you nothing. All right? Good job. So on this specific problem, what method do I give you to find my line's slope? What part of that problem is related to the slope? Perpendicular. I know that my line is perpendicular to, and the symbol for that is this. So I don't have to write the whole word perpendicular. It's perpendicular to, what was it, 2x plus 4y equals 5. So how does that help me get my slope? What do I have to know first in order to use that information to get my slope?
You know your slope.
Yeah, I have to know this guy's slope, and then I can figure out what my slope is, right? So if one line slope was 1/3, what would the perpendicular slope be? -3. You change the sign and you flip it. Parallel, completely the same slopes. That makes sense. Perpendicular, totally opposite. So not only do you change the sign, you also flip it. So what is this guy's slope? Yeah, I don't know yet. So you get 4y equals -2x plus 5. Divide by 4. Y equals -1/2 x plus your peers and shit. Its slope is -1/2. I don't care about this y-intercept, right? The only reason I need that line is to find my slope. What is my slope going to be? 2. Cool. Right, because it's perpendicular to this guy, so it's the negative reciprocal. And I also need a point. Do I give you a point?
Yeah,
-1, 2? Okay, cool. And then there's a couple different ways to do it. Some of you guys know how to use mx plus b and solve for b. And then the other way to do it is to just plug all the information into this big old dude here. Can't remember, how did I do it? I don't remember. I use this guy. Okay. You guys with me on that? You understand? So I could put, in this blank, could go so many different things. I have to give you enough information to figure these 2 things out. So these 2 things are what you need. Period. If the point I give you is the y-intercept, that kicks ass, because then I know b, I got less work to do. This was not the y-intercept, shit. I can't just put a 2 in for b, because that's not the y-intercept. Maybe. Okay. So you can see the rest of it. So plug a 2 in, plug -1 in for the x piece, 2 for the y piece, solve for y. How do you check the answer? Look at the answer. But in general, how do you check the answer? Well, for one thing, this point's got to work. So plug the point into your answer and make sure it works. Right? All right. Yeah.
8.148.
Oh, so this one's asking you to sketch a graph. Right, the 6 minus 3x, that one. So 8.448, 8.1 48, right? Mm-hmm. And it gives you this. So what kind of function is that?
That's y equals a negative.
Totally. So what's the slope? Good. Slope is -3. Now put it over 1. And the y-intercept? Yeah, so then you can just graph it. You plot the y-intercept, you go down 3/1. So you don't have to make... We should be getting away from making tables for everything in the world, right? Because if it's linear, I don't need to make a table. Now, if they gave me like a cube, maybe I need to make a table because we're not really totally familiar with what that looks like.
Thought about it too hard.
Exactly, right? This book likes to do that. It likes to kind of repeat stuff we've already done, just in a slightly different way of wording it. I don't know if I like that or not. I'm still thinking about it. Yes?
Can you go over 2D on the practice list?
Oh, yeah. Okay, so that was... Okay, good. Beautiful. So one thing I didn't talk about with the absolute value stuff earlier is the inequality special cases. So let me ask you this. If I said, solve this, I know it's a special case. Why? What's different up there? It's an absolute value, so...
Negative.
There's a negative on the other side, right? So this is asking me, what x's make the absolute value bigger than -5? Well, what's true about any absolute value? It's positive, so how is it related to 0? It'll be bigger than 0. So it's bigger than any negative number. So what x's make this true? All of them do. The answer here is all real numbers. Right? Anything you plug in, is it going to be the absolute value going to be bigger than -5? Of course it is, because it's going to be positive. Any positive number will be bigger than -5. So really what it's saying is, what positive numbers are bigger than -5? All of them. I like it. I really want this to make sense. So if I had this, remember what was true here? What was the answer here? No solution, because there's no way to make the absolute value equal negative. This is saying absolute value bigger than... Oh yeah, that's everything. I can't make it equal -5, but because they're always going to be bigger than -5. I want to see that's the difference there. So this is all real numbers. This is no solution. And some of you guys are going to use this as an example of why math is evil. Look at that math shit. Math is shit. Look at that same thing. It's two different answers. No, it's not the same thing. There's no way I can make it equal and negative. So because it's always bigger. So this has got to be everything. Any number I put in there, the absolute value is going to be bigger than -5. Of course it is. And for the same reason, it can't equal -5. There's no way to make it equal -5. So what if it would have been this? What's this asking you to do? Make an x so that you make the absolute value less than -5. Is that possible? So what's the answer? No solution. Kick ass. So that problem starts off with something we know how to take care of. What was it 3 minus 2x? I mean, what's the first thing I got to take care of there? What's there that shouldn't be there? The -2. I need to isolate the absolute value. So at first it looks like everything's going to be great. But then I divide by -2, and what happens? A couple things. You become a -2. There, Chuck. Good. Divided by negative, so the sign must switch. Why? Because it does. And then what situation am I in? Same situation. Can I have an absolute value less than -1?
No.
X can't save this equation's ass. No solution. There's no x that can save this. No solution. What did I put? Did I put empty set? No, I just put no solution. You could put, that's the empty set. If you make zeros like this, stop doing that. Because in math, that means empty set. Sounds like it means the same thing as 0, but 0 wouldn't be empty. It would be 0. 0 is a number. This means nothing. This means the absence of thing. Yes.
Do we divide by -2 because that would end up distributing out, or why is it that that one cancels out? Like, why is it that the 3 minus 2x doesn't go over -2 into a fraction as an absolute value?
Because the -2 dies.
Because
It's not there still to go there.
it's being multiplied out into
Yes.
absolute value. That's
And so everything we've done has been predicated on absolute value compared to a number somehow. So if I have extra shit there, I got to get rid of it. And then I can look at it the way that we talked about.
And it's only sitting outside through the multiplication. It's only sitting outside because it's being multiplied in.
That's right.
Yeah.
So the only way to get rid of that is to divide. So that's like the coefficient of this expression.
Perfect.
So divide it to get rid of it.
Like we don't distribute the -2 at all then?
We can't. We can't. I really want this to make sense. So absolute values are not exactly like parentheses. They're a little stronger. So it's sort of the difference. What would I do here? Could I bring the 2 in? All right, let me make sure you're looking at the right. Could I bring the 5 in?
No.
No, I'll make sure you're looking at the right 2. You have to first do what's inside and then square and then, yeah, right? So, but here, could I bring the 5 in?
Yeah.
Totally, I love it. So it's because I have something that I want to do. The parentheses just organize shit. If I have something else to do, I got to do that first. So here, if I have this, the absolute values are like parentheses with something else to do. So I can't bring the 5 through officially. I have to do inside here first. Maybe. To be completely honest, you actually could bring the 5 in. It wouldn't change it because it's positive 5. But just to be safe, I just divide by 5 and this is part of something else. I divide it, just get rid of it. Because you can't bring a negative inside an absolute value because it doesn't work that way. I don't know how else to say that. Okay, maybe.
We have 6 weeks. Thank you.
Oh, sure, okay. But that's not, I mean, this is fine, this is not good, because it's not just grouping, it's asking you to do something more. So absolute values are like parentheses and exponents, it's at that level. So I can't just distribute across them. Not directly, you got to be careful about when I can and can't, so just never do it. That's a good, safe way to be. Okay. I wasn't joking when I said it was on you guys. Whatever the hell you want to talk about. Whatever. It's up to you. You guys are out there going, if we don't ask questions, we can leave early. Yes?
We were reviewing right now.
Totally, yeah. You had me excited. I thought you had a question. Yes?
So then what does the absolute value do on 5G? Like, we just solve it like normal?
Yeah. 5D. Is it just absolute value 3x minus 7 equals 6, or how did it start?
3x minus 7 are little thingies, and then minus 8 equals -2.
I like it. So this is a really good example of what I was saying here. Is the absolute value by itself? No, because there's a minus 8. So you add the 8. Is the absolute value by itself? No, it's -2. So you divide the -2. I mean, you see that? You isolate the absolute value first. I like it. Maybe.
You probably do 6F. You only want to.
Did I skip 6F? No, there it is.
No.
What happened? Oh, you want to go through it?
Yeah.
All right. So you got to help me. I don't have here what it started off as.
So 2 minus 3 over x5. And then division bar, and then 5 over x squared. Minus x over y.
Okay. So there's a few different ways to do this problem. I showed you a way that's sort of related to the way I show you how to solve rational equations. So looking at every single fraction in here, what does he need that everybody else has?
X squared.
Yeah, he needs an x squared. And a y, right? Let me stop. What's up? How we doing? All right, so what's he missing?
X.
An x. What's he missing? Y. What's he missing? X squared. Now the beautiful thing, if this was a rational equation, I would multiply both sides of the equation by the denominator because they're all the same. Because there's two sides to an equation, so it makes it legal. Well, there's two sides to this big-ass fraction, so I can totally multiply top and bottom by x squared y. That kills all of the internal fractions, right? I have fractions inside of fractions. It's horrible. Makes less sense than Inception, right? And I have to watch that movie again with a notebook. I still haven't done that because it gives me a headache. But if I multiply the top of this by x squared y and the bottom of this by x squared y, it'll cancel everywhere. So what's left alive? Cool. Now there are other ways to do that. Some of you guys seem to like putting these together and then flipping it, right? That's beautiful. That works. To me, it's just extra stuff to write. But if it's easier for you to see what's going on, I love it. So I can put these together, multiply by the reciprocal, stuff cancels. If that looks better for you, do it. I don't like it because it's more writing, but I'm lazy, so don't, be better than me.
So the parentheses helps cancel everything on the bottom off, that's why.
Yeah, so what I'm doing right here is I got a fraction. I got this over this. So I can multiply top and bottom of that big-ass fraction by anything I want to, except 0. So I'm going to multiply by what all the little tiny internal fractions have on their bottom, so they die. Right? I killed all the internal fractions. I feel like a doctor or something. Huh?
Are we going to finish the equation?
Sorry?
Are we going to finish the equation? It's not done yet.
Why is it not done? What's that? What else can be done?
We need 2x squared y minus bx can turn into x, 2xy minus 3.
Just taking off the
Oh, you can take an x out, sure, but does it cancel anywhere?
No.
So there's no point. You can factor the top totally, but and then you can see nothing cancel, so there's nowhere to go. So the last thing you can try to do is reduce this fraction. It won't reduce, so I'm done. I like it. But you're right, you have to check that out every time. But that one, there's nothing that's going to be in common. If there was an x here, then the x's could cancel everywhere. Yeah, but there ain't. Oh, you guys are always like, somebody ask a good question, come on. We could do examples of problems. We can, anything you want to do is going to get you ready for tomorrow.
The word problem.
Oh yeah, okay. What page was that? Okay. Yeah, all right. So it tells you 2 athletes run 10 miles. So that's awesome. It's a beautiful start because there's nothing unknown in that first sentence. 2 athletes run 10 miles. It's an awesome sentence for algebra class. Nothing's unknown. So I got my 2 athletes. I look and I see, do they give them names? One of the athletes and the other. So I got one athlete and the other athlete. And what do I put up here? What's the formula?
DRT.
Yeah, distance equals rate times time. So where's 10 go?
Distance.
No way. Alright, I like it. So this box process is kind of nice because it kind of focuses you on what do I need to know and then where does it go. One of the athletes runs 2 miles an hour faster and finishes 10 minutes ahead of the other athlete. Oh, good. All right. So I don't know if you remember, we did a problem in class where it was like a certain number, there was 2 minutes. So 10 minutes, everything else is in hours, right? It's miles per hour. So 10 minutes is how much of an hour?
10 over 60.
10 over 60, which is 1/6. So 10 minutes is 1/6 of an hour. So I got to use this number. Let's see if I remember it this time. I got to use that number when it's time to use that. All right. So what is it that I don't know? What is the question, actually?
I don't know which one.
Say again?
We don't know which one.
No. Three things it could be I don't know. Distance, well I know distance. Rate and time. What is it that we don't know? The rate. I don't know the speeds, right? But I do know that the one athlete, what is it? One of the athletes runs 2 miles an hour faster than the other one. So which one is going to be X? The one or the other one? The other one. Right? One athlete runs 2 miles, 2 miles an hour faster than the other one. So who do I have to know first? The other one. And then I can do what to find the one athlete? Add 2 to it. So if this guy is X, this guy is 2 faster. There you go. That's how you figure out who X is. We have to do something to figure out the other one. Maybe. And really, the nice thing with this, say again?
It's not 2x, it's x plus 2.
Yeah, if they meant 2x, they would have had to say he runs twice as fast.
Oh, okay.
2 mile an hour faster is adding 2. Yeah. You can always just give yourself a number. If I'm going 5 mile an hour, then 2 mile an hour faster would be 7. Yeah. So now what could I put here? Just looking at what I've got. Because careful.
10 over.
So if D equals RT, what does T equal? D over R. So T equals D over R. T equals D over R.
And then you said it was 10 minutes.
Yeah, exactly. So now, we've done several of these now. I don't know if you guys can remember over all the ones we've done. I filled in 4 boxes. The last 2 I got just from what I could see right there. I got it from the equation. And then, how do these relate? Are these equal to each other? No. Right? One guy ran faster. Well, he was running faster, wasn't he?
Yeah.
So let me see if I can make this. His time, is it more or less than this guy's time? Less, because he's going faster, right? So whatever this guy's time is, let me see if you guys can get this. He ran 10 minutes faster, so 1/6 of an hour faster. So if whatever this guy's time is, you have to take 1/6 away from it to make it the same as this guy. Because he ran faster. His time is less than this guy's time, isn't it? No. So we did an example where these were equal to each other. They did it in the same amount of time, so the equation was this equals that. Another situation could be they took a total of 4 hours. So this plus this equals 4. That could be another situation. Or they're different by a certain amount. Right? You can even do it that way if it makes more sense. This time minus this time is 1/6. I don't know if that makes more physical sense for anybody. This guy's time, the slower guy's time, minus the faster guy's time is 1/6 of an hour. And I don't know if you guys see how those are the exact same equation. Or if I subtract that and add that, I get this. They're the same exact equation. Just whichever way makes more sense, the physical reality behind it, whichever way makes more sense. And now it's just give everybody what they're missing. Now it's just solve that rational equation. Okay. No? What's up? So you guys have a bemused face. I like that. Never used the word bemused in public before. Yes?
Do you have any problems?
Say again?
Like filling liquid problems? Do you have any of those word problems?
Liquid problem. Did I give you a liquid problem?
I'm not sure. I do all my work online.
Oh. Was there a liquid problem online?
I haven't gotten there yet.
Oh, okay. I don't think we've hit the liquid stuff yet. I know what you're talking about. Like, there's a 5% solution of saline, and the nurse needs a 7%. How much? Yeah. That's in our future. Yeah.
So that's that problem to add to all 3 denominators, right?
So now you got to say, what's this guy missing? He's missing a 6 and an x plus 2. Make all the denominators the same so you can kill them.
Can you do 2b for the second question?
Sort of. Because there's several different versions out there. So to be fair, I have to do something like that one. So basically everybody's 2B. Let me see if I can make one up on the spot here. Everybody's 2B looks something like this. Right, you had a single digit and you had the cubes. Right? This is from the last quiz. Quiz 2B. If anybody says that's not what they have for 2B, I'm going to hit you. This is one like 2B because there's several different versions of the quiz out there. Oh shit, this is going to be the hard part to do. Let's see. You can do it, Jeff. Oh no, get out of there, Em. Yeah, alright, so far so good. Oh, that's right, that's how I do it. Okay, so, this won't be as bad. And so here is going to actually be, I'm sorry. Alright, let's see what Jeff did here. Did Jeff make something that makes any sense? Alright. So now you just attack it. So I'll do this part. Alright, I've done 1/4 the problem for you. This is what threw people off. This was the part that most people missed. Some people did everything else perfect and then just didn't factor this guy.